Hello and welcome. Today we're going to be looking at a TMUA style question involving dividing a polynomial by a quadratic expression. So we're given a polynomial ax cubed minus x squared plus bx plus 15, and we're told it's exactly divisible by the quadratic expression x squared plus 2x minus 3. Now, this might seem a little bit confusing because we're used to dividing polynomials by linear expressions, something like ax minus b, which this quadratic clearly is not. So we need to figure out what's going on and eventually calculate the value of a plus b. What does it mean for this polynomial to be exactly divisible by this quadratic? Well, it's easier to understand if we think about a type of division that we're more comfortable with. So let's imagine that n and m are integers. In this case, we say n is divisible by m if and only if n is a factor of n. So, for example, if we take 15 and 3, we know that 15 is divisible by 3, and that, of course, is because 3 is a factor of 15. So, what this really means is that our cubic has a factor squared plus 2x minus 3, which means we can write ax cubed minus x squared plus bx plus 15 is equal to x squared plus 2x minus 3 multiplied by some other polynomial. Now, since we have a cubic on the left and a quadratic on the right, we know this is going to be a linear term over here. So it's going to be x plus or minus some constant, and we can actually figure out what the coefficient of each of these terms are. So for example, x squared times whatever our x term is has to be ax cubed, the x cubed term over here. And so we know that this has to be ax. And similarly, whatever the constant term is, it has to multiply with minus 3 to make 15. So we're going to know that it has to be minus 5. Okay, that actually isn't terribly important, but it does give us a way to solve this problem. We can expand this out, start comparing some coefficients, get some equations in A and B, and hopefully solve for A and B, add them together, and we'll get A plus B. But we're going to take a slightly different route. So rather than expanding out, we're going to fully factorize. So x squared plus 2x minus 3. The factorization of that is going to be x minus 1 times x plus 3. And we have this other term, ax minus 5. And from here, this is helpful because we can sub in values of x and make the right-hand side equal to 0, which is hopefully going to simplify our calculations. Now, a particularly sensible value of x to use is 1, because we're going to get a minus 1 plus b plus 15, and x equals 1 is a root of this cubic, because x minus 1 is a factor. So on the right-hand side, you get 0. And this is a very efficient path to our solution, because we are actually getting this a plus b after. We can simply rearrange for it to get a plus b equals minus 14. And that tells us that the answer is option B. There we go. Okay, I hope you guys enjoyed this problem. Thank you so much for watching, and I'll catch you all in the next one.